Hello, boys and girls. This is your video for 7-1 practice problems. All right, I do not have the video turned on today because it's not working right with the pen. It keeps going on and off and it's very distracting, so I just turned it off. You're just going to have to look at my screen for today. Okay, so in the 7-1 practice problems, we're graphing systems of equations to solve them. We know that if two lines intersect at one point, they have one solution. Okay, that's what's called consistent, if they have one or more solutions. They are inconsistent if they have no solutions. An example of that would be parallel lines. There's no solution that solves them both. If they only have one solution, they are classified as independent. All right, and if they are the same line and have infinite solutions, they're dependent. So I would recommend keeping this little bit of information with you when you're working on your assignments because I can't even remember all these words. Use the graph to determine the number of solutions the system has, then state whether the system of equations is consistent or inconsistent, independent or dependent. All right, so the first two are in slope-intercept form. Well, no, I take that back. This one's not. First one's in slope-intercept form, and you think they would have given you different graphs for these. It's kind of lame, actually, that you got to look at. And even on the practice on McGraw-Hill, it's the same picture. You just got to kind of find which one they're talking about here. So for this first one, y equals x minus 1. This is y equals x minus 1. That's this line right here. All right. And then y equals negative x plus 1 is this line right here. As you can see, these two lines have 1 point, so they're consistent. And this is multiple choice on the assignment. Consistent, you don't have to write it all out. They're not inconsistent, and they are independent because they have one solution. Independent, like Rudolph. I am independent. Remember that show? That's cute. Love Rudolph. All right. So let's look at the next one here. Now this one's not in slope-intercept form, so the first thing we have to do is fix it. I'm going to subtract x from both sides. That gives me negative y is equal to negative x minus 4. And then, okay, so now what we need to do, we cannot have a negative y, so we're going to have to multiply each term by negative 1, which will give us y is equal to a positive x plus 4. Okay, but what you notice here is now these are the same line. They have the exact same equation. See, this was the second one, this was the first one. They're the exact same line. So if they're the exact same line, they are consistent because they have one or more solutions. But they are dependent because they're the same line. So this would be consistent and dependent. Right? Okay, so I guess I probably didn't have to fix that because they've labeled these with the original thing. So I probably didn't even have to do that. I could have just found which line was this one here. Yeah, see, it's marked this line. And this one is also marked this line, so I didn't have to do that work. We will in the future, though. All right, number 3, y equals x plus 4. We get rid of that. Y equals x plus 4 is, y equals x plus 4 is this line right here. Oh. This line. And 2x minus 2y equals 2 is this line here. And I think we're both getting the idea here. These are parallel, all right? So because they're parallel, they have no solution. There is no point that solves both of these. They're inconsistent. All right? And they are dependent, or no, they're not dependent because they're not the same line. They're not independent because they don't have one solution. They're just inconsistent. So if you're inconsistent, that's all you are. You don't get another word. All right, number 4, we have, let me erase these. I'm not in love with this little picture they've given you, clearly. All right, number 4, we have y equals 2x minus 3. Y equals 2x minus 3 is this line right here. And 2x minus 2y equals 2 is this line right here. They have one solution at their crossing point right here. So these two lines are consistent and independent. One solution. Dependent. Okay. And that's how you do those. Moving on to more interesting and challenging stuff. Clear. Okay, determine the number of solutions the system has. Then state whether the system of equations is consistent or inconsistent, independent or dependent. So see, I've got my little words down here because I don't want to forget what those are. All right, so we're just looking at these equations. I noticed that the slopes of these two equations are different. This has a slope of 1. This has a slope of 1/2. That is a one solution thing. These lines will intersect at one point. If the slopes are different, they will intersect eventually at one point. So this would be consistent. Now I'm going to start shortening things. And independent. Again, on the McGraw-Hill assignment, these are multiple choice. All right, now this one is a little bit more challenging because both of these equations are written in standard form as opposed to slope-intercept form. So we're going to have to fix that. We have 4x minus 6y equals 12. We want to get it in slope-intercept form. So let's subtract 4x from both sides. That gives me negative 6y equals negative 4x plus 12. Divide everything by negative 6. And I get y equals negative over negative gives me a positive 2/3 x minus 2. Okay, so that's the first equation. Second equation, negative 2x plus 3y equals negative 6. All right, add 2x to both sides, which gives me 3y equals 2x minus 6. Then we divide everything by 3. It gives me y equals 2/3 x minus 2. Well, what do you notice about these two lines? They are identical, okay? So this is consistent because it has one or more solutions. It has infinite solutions. And they are the same line, so this is dependent, not Rudolph. Okay. We're going to do the same with 7 and 8. I may not do all of these because I don't want this video to be humongously long. Okay, so for number 7, we have 8x minus 4y equals 16. Subtract 8x from both sides. Negative 4y equals negative 8x plus 16. Divide everything by negative 4. Is it just me, or do you guys going, oh, we're dividing by negative because we just did all those inequalities? Yeah, it's kind of freaking me out. Negative divided by negative is a positive, so this is going to be 2x minus 4. The other equation is negative 5x minus 5y equals 5. Add 5x to both sides. Negative 5y equals 5x plus 5. Divide everything by negative 5. Now we don't have to flip the sign. This is an equation. Y equals negative 1x, or just negative x, minus 1. Okay, these two equations have different slopes. That means they have one solution. If the slopes are different, it's one solution. If the slopes are the same, it's either infinite or none. Okay. But slopes are different, one solution. So this is going to be consistent and independent. Okay. All right, so number 8, you would do the same way. I'll go ahead and do it real quick. 2x plus 3y equals 10, and 4x plus 6y equals 12. Subtract 2x from both sides. 3y equals negative 2x plus 10. Divide everything by 3. That gives me y equals negative 2/3 x plus, let's say 3 1/3. Hope we don't have to graph this thing. Subtract 4x from both sides here. That gives me 6y is equal to negative 4x plus 12. Divide everything by 6. And that gives me y equals negative 2/3 x plus 2. All right? Are the slopes the same or different? Well, the slopes are identical. They're both negative 2/3. So that means these lines are either the same line or they're parallel. Okay? Because they have different y-intercepts, this means that they are parallel. Okay? So there is no solution. This is inconsistent. Because if you are and because it's inconsistent, there's no other word. You can't be dependent or independent because you're not intersecting at one or infinite places. You're not intersecting at all. So this is just inconsistent. Okay. Up next, I'm not going to do these two. These two are going to be done the exact same way. Actually, these are already in slope-intercept form. Know that these two slopes are different. So this is going to have one solution. It's going to be consistent and independent. These two are both in slope-intercept form. Also, one solution. If the slopes are different, there's one solution. They are consistent and independent. Now we get to this next section here. They want you to graph them, determine the number of solutions it has, and if it has one solution, they want you to tell what it is. Well, you have access to the Desmos graphing calculator, so that's what I want you to do. All right, for number 11, let's hop over to Desmos. Let me put this on pause so I make sure it's going to work right. Okay, it totally works right. So this is number 11, all right? They're both in slope-intercept form, so I just type them in here. And you're pretty savvy. You probably already know that you don't have to put them in slope-intercept form for Desmos to do it for you, but it's good practice. Here's the one line, y equals -3. Here's the other line, y equals x minus 3. And if you want to know what their point of intersection is, you just put a point there, and it'll tell you it's 0, -3. So the solution for number 11 is one solution, and the point is 0, -3. That solves both of them. Moving on, let me go back to here. Number 12, these are also both in slope-intercept form already, okay? So we can just go over to Desmos. And again, I know you can go over to Desmos and do them not in slope-intercept form, but it's good to know how to do it. Here's problem number 12, okay? We have y equals 4x plus 2 and y equals -2x minus 4. Here I have graphed them. They have one solution, obviously, and that solution is -1, -2. Okay, that's how you find it. Okay, back to the flip chart. Here we have 13 and 14. 13 is already in slope-intercept form, so we can hop over to Desmos, and I've pre-entered these, obviously. This is number 13. Once you graph these, you see that clearly they have the same slope. Both of them have a slope of +1, but they have different y-intercepts, and you can see that they are parallel. So therefore, there are no solutions, and they are inconsistent. Okay, number 14. Now we're having a problem because these are not in slope-intercept form. So x plus y equals 4, pretty close to slope-intercept form. We just need to subtract x from both sides, and that gives us y equals -x plus 4. And then over here we have 3x plus 3y equals 12. Subtract 3x from both sides. And like I said, you could just go over to Desmos and enter these slope-intercept formed, and it will still graph them. I'm just trying to show you good form here. All right, divide everything by 3. That gives you y equals -x plus 4. And what do you notice about those two equations? Heck yeah, when we look at these two equations, I graphed it, but you know what? You only see one line. You know why? Because they're the same line. They're both here. All right, both of them are here. There's a red one underneath the blue one. All right. So these would be infinite solutions, and these are what? Dependent, because yeah, infinite solutions. Go back to my words. If they are the same line, They are consistent and dependent. See what I mean about keeping those words handy? Really helps. Okay, 15 and 16, both of these should be put in slope-intercept form. Not too hard. All right. X minus y equals -2. Subtract x from both sides. Negative y equals negative x minus 2. Multiply everything by -1, and you get y equals x plus 2. For the other one, we have negative x plus y equals 2. Add x to both sides, and you get y equals x plus 2. Again, these are identical, so therefore they are the same line. Okay, and I do have them graphed over here on Desmos. It's kind of anticlimactic because they're the same line. It's one line. So, pretty boring, actually. Okay, and number 16, we want to put these in slope-intercept form. So we have 2x plus 3y equals 12, and 2x minus y equals 4. Subtracting 2x from both sides gives us 3y equals negative 2x plus 12. And then we divide everything by 3. And that gives us y equals, oh, the tornado siren's going off, so you know exactly what day and time I recorded this video. It was on Monday, March 1st at 12 noon, plus 4. Okay, this one we're going to subtract 2x from both sides. Don't worry, kiddos, I am to the end. I believe this is the last problem. Negative y equals negative 2x plus 4. All right, multiply everything by -1, and we get y equals 2x minus 4. These do not have the same slope. Therefore, they have one solution. It will be helpful to use Desmos for this one because it will help you figure out where the solution is. See where they cross right here? If you put a point right there, it'll tell you the solution to this system of equations is 3, 2. Super fun, right? Super fun. All righty. Like I said, I think that's the last problem. Yeah, we're not going to do those word problems. They're super fun and everything, but we don't have time for that. So yeah, that's all, folks. You guys go on over to McGraw-Hill and get those practice problems done, and then I'll have a quiz review for you tomorrow. All right, have a great day.